Alright guys, I'm basically finished with this box after reassembling the whole thing. I took it all apart, as you guys saw, myself and Ben. Yeah, so I've just finished shimming this up. So basically when you set these up, you've got a shim in the input shaft, bearing, carrier, snout, whatever you want to call it. And then the cut for the back of the main shaft is supported inside the tail housing. So basically you've got to shim this so that you have, you know, the right amount of drag and no end play, so that way. So what a lot of people do is they just put their hand on, you know, like the input shaft and then the back of the main shaft and just kind of feel it. But that's not good enough for me. You know, you can't really feel, you know, 0.3 of a mil, 0.2 of a mil. So I've actually set up the dial indicator, as you can see, and then I'll pretty much just get a screwdriver on the input shaft here. 0.02 mil of end flow. So that is good enough for me. I don't have a shim that will actually correct that anymore. It's time to pretty much take all this apart again. Well, tail housing, this. Put some Loctite 518 on it, which is an anaerobic gel. Very important for when you're doing surfaces that have a surface that basically preload a bearing. And while I got the camera, I might as well show you guys inside the G-force case. Yeah, this is it. As you can see, there were, well, as you remember I should say, there were a bit of scoring on the input shaft gear, which I have cleaned up. I'll insert some photos on the screen. So I spent a good few hours on that, basically grinding it back with a Dremel, like a really mild stone on the Dremel, and then kind of buffing it. Used a feeler blade, pretending this is the input shaft gear, used a feeler blade with some sandpaper wrapped around it, and just, you know, buffed it all smooth. And then final steps, coming over with some Scotch-Brite and just buffing it right up. And it has actually turned out pretty nicely if it will focus. And while I was at it, I took the whole main shaft apart, checked all the gears, they seem alright, checked all the synchros, they all seem okay. As I said, thoroughly cleaned it out. I guess one extra little thing is I have tapped a M18 hole in the box. I'll show you guys later when I'm actually putting it back together for good. So that will allow us to, as you can see in there, that will allow us to unscrew that and inspect the input shaft, see how it's wearing. Hopefully now that the preload issue is fixed, it's not going to have any more issues like it. You know, a little bit of radial movement, which is, you know, up and down, is okay. And just feeling that's the perfect amount of drag. It will turn when you turn it, but basically when you stop turning it stops, which is good. And as I showed you, end float is good. That's how I set up the dial indicator if anyone is actually interested. Anyway, I'll stop boring you with this shit. I've also got a new speedo drive gear, which I've done a calculator on the net, and that should actually work, hopefully, with the speedo drive gear I've got in the box. I actually put my old speedo drive gear in because I put my old box apart to get the fifth gear off it, and it turns out it's the same ratio. But because of the first gear 295 ratio, that changes basically the final drive ratio out of fifth gear. So that was a waste of time. And actually I'll show you guys another thing that I noticed. It's a shame I've actually put it back together without filming. I didn't have my camera yesterday when I did it. But basically the Aussie T5s doesn't matter. Pretty much, I'll try to get some photos on the screen for you, but where the end of the main shaft is to the tops of the roller bearings inside the input shaft, Aussie box, it doesn't matter, it's accounted for in the input shaft bore. Like there's a little bore in there with the needles sit in. But because this is an American design box and main shaft, and input shaft I should say, they actually run a spacer ring. So I couldn't get one of those because no one in Australia really has them. So I had to actually get a hardened steel thrust washer. So this is 35mm with a 20mm ID. So I had to firstly chuck this up in the lathe and bore this out to 20, shit, I can't remember what it was, 26mm I think. Then I had to make this little jig up, so hard when one-handed. Basically it clamped on there like that, obviously concentric, so I could turn down the outside to fit inside the input shaft. So as you guys can see here, I've kind of done all the calculations and all the measurements. So yeah, that is now in there. That's how it should have been. It probably won't make that much of a difference, but it will stop the needles basically floating out of the input shaft, or further than they should. So yeah, I'm going to stop blabbering on, and as I said, seal this box up, get it all ready to go, chuck the top cover on, check that it shifts and everything, and then that's one more thing off the list, and then and then when I get one of the boys here next week, hopefully, we'll chuck the box in. I've also got a new clutch setup coming, so I'll run you guys through that when I get it, but basically it's a custom Kevlar setup, so it will take a lot more heat. So yeah, I'll see you in a sec. Holy moly, it's done. Feels great. All back together. As you can see, very profesh. Feels very nice. I can get all gears, which is a bonus. So while it's up on the table and before I head home, I think I'll show you guys my nifty little input shaft inspection. So as you can see here, this is where I've drilled it in. And what a sexy job on that welding, if I say so myself. So in a nutshell, M18 bolt turned down, that was the head of the bolt, and then a M10 I think cap screw cut off, tapped inside that, and then fully welded, as you can see. There it is. Hopefully, probably won't be able to see anything. It's kind of hard to show you guys on this camera, but you can kind of see there, I can see the input shaft spinning, I can see all the teeth on the gear, so I'll be able to do inspections. Alright guys, so it has been a week since I last shot a video on this issue, and 2-3 weeks since this guy was here.
Seems like just yesterday.
So now he's come to inspect my handiwork. So I've got new clutch set up. I'll run you guys through that in a sec. Man, how many clutches have you seen me go through in the last few years?
Well, I stopped counting when I ran out of fingers and toes. No, it's not that bad. I think it's maybe one a year.
Yeah, on organics, but we've changed to Kevlar. So I'm gonna pull that. I've literally just got that in the post from Scotty at Western Clutch. I'll show you guys that in a sec. Box is back together. Very, very nice. It's got a really good feel to it. You know, it's nice and tight. There's not much, enough drag, but not too much, I feel. So the plan is we're going to put this back in, and then we're going to set up Ben's fag detector.
Yep.
And we'll see if the issue is fixed, which it very well should be, but
hopefully.
So I guess we'll run you guys through the clutch setup quickly, and then we'll go about putting this in. So whenever I get a clutch from Scott, he runs through all the dimensions and sets this thing up to be absolutely perfect. That is one of the reasons why I use him and Western Clutch. They are, in my opinion, the absolute best. I've got a new spigot bush. I've always had my aligning tool. New firewall bolts, a new bearing for the throwout. These are my old plates, as you probably saw earlier. I can't remember whether we shot these. They probably had another 4 months left on them, but I figured while the box was out, I might as well go fresh. So this clutch, I've got a new top cover now, which has restored the clamp force. So we've got, as you can see, at -1, so fingers 1 mil below the cover. We've got 1,000 kilos, and it goes up to 1,100, 1,300, 1,300, 1,200, and then as the fingers raise, as the clutch wears, the clamp force, well, I guess it grows, and then it peaks, I guess, and then drops back down. So I'll grab this 5mm hex socket and zip this off and have a look at this. Okay, so get a load of this goodness. So you've all seen this before on my various other twin plate videos, but basically this is the Kevlar setup that we're running. Ooh, very nice. So these are an absolute bitch to set up, so Scott really hates these, but he's such a good guy, he did it for me. These are meant to last about 3 to 5 times longer than organic, which is what that facing is. These are much more tolerant to heat, hence why I did it, because this car carries a lot of load all the time. And reverse gear is still very tall on this, so I normally smell the clutch in reverse. Since we did the diff ratio, it's been good, like first through to, or everything, taking off in first. But I just needed more longevity. So that's that. We've got our alignment marks. So we've got to be very, you don't want to get them too dirty. So yeah. Intermediate plate. And this is your main basket, flywheel face. So all nice and labelled for me too. So anyways, we may as well get cracking and put this in, put the box in and order some dinner.
So what do you reckon, 15 minutes to get the box in, half an hour to get the clutch on?
Maybe. We'll see. Oh, and also, you can see, so this is called the knife edge. This is basically what the springs on this pivot on. So the wider this is, the less clamp force you have on your clutch, and the closer it is to the center, the more clamp force. So I don't know if I ran you guys through this last time, but Scotty and I, last time I was at his shop, we played around with moving this in and out to, because basically the less clamp force you have, the longer the clutch lasts, rule of thumb. It wasn't so much the case with this twin plate, so we ended up just leaving it back where it was basically. So, but yeah, you can, Scotty basically machines this out and puts a custom ring in and then machines that to where he needs it to be. So yeah, not too many people will be able to show you the real workings of a clutch, especially a full custom clutch like this. And I run the auto flex plate because this is a one-off unit, so that's for the starter motor to obviously start the car. So, and new unis. I don't know if I said that already. So we already did those ones. Rear, center CV, and front.
And center bearing.
And center bearing. So you can check that in another video if you're interested. But yeah, let's get this thing up in the air and do a bit. What are you doing, Ben?
So, because I noticed there's a bit of Loctite debris built up in the end of the crank there, what I'm making is a special thread chasing bolt. So what I've done is cut a flute into it and I'll widen it a little bit so there's a cutting edge on there, and basically what we'll do is we'll deburr it, lube it up and send it into the crank. And what it'll do is these flutes will catch all the debris and old Loctite and stuff and bring them out without cutting the hole that's in the end of the crank. So if you use a fresh tap and you ran that through there, you'd end up actually cutting more thread out of the form, or cutting a second thread, or just generally making it a bit sloppier. So normally you wouldn't use a tap to chase it. There's special chasing taps, so you don't end up recutting the thread and making the connection looser. So a safe bet is a bolt that's modified like this, so you can do it when you're doing cylinder heads and all kinds of things like that.
Learn something every day.
So a couple of ways you can do it. If you don't need all the length, then you can just cut it straight. That's the easiest way. And you cut it on a slight angle so that you've got a cutting edge there when you turn it clockwise. So it's not just a straight slot like that. I've actually cut it at an angle, so you've got a cutting edge. If you really need the full depth and you only have a bolt that's here, that's the right length, you can cut it on an angle. So you can cut the flutes on a spiral angle and that'll bring you all the way up to the end. So when you're using the cutting disc, you can see you can only get to about there. But if you cut it on an angle, you'll be able to spiral all the way up to the shoulder of the bolt.
Well folks, there you go.
That long.
Keep that one in the memory bank.
So yeah, really good tip, because generally you'll always have old bolts left behind, especially for clutches and cylinder heads and things where you're always replacing them.
It's a worry when you've got bolts left behind that were new, that were meant to be in there.
Yeah, absolutely. So yeah, so there's a top tip. So you cut a couple of flutes. So on this case, we'll probably just do 2, but yeah, you can cut 3 or 4 or however many you need.
Awesome. Well, I'm going to keep on carrying on. I'll meet you over there.
So you see, these are the clean ones, and then you've got all the Loctite and gunk in there. So I'll start it off with my hand. There's a little bit of lube on the threads. Okay, so you can see here's a clean flute, and here there's all the Loctite and junk that was in the threads. And get stuck in the flutes, so you can clean that out, keep going.
Happy days.
Yeah, you could even modify this and make the flute larger, because you don't need all that thread there, so you make a big flute on a bit of an angle and it should be self-cleaning.
Yeah. Not a skin flute though.
No. No.
Alright, tell us a story, Ben.
Well, my computer's starting to boot up, but anyway, so last time before we stripped the gearbox out, we took some vibration measurements, and I went and talked to the boffins, and they came back and told me you've got a clear gear mesh defect frequency.
So it wasn't bearing?
Wasn't bearings, it was defect frequency for gear mesh. So we did the calculations, and it works out that the engine was turning at 1400.
Tell him, you just gave him the data.
Yeah, so I gave him the data.
You didn't tell him anything
right,
except what it was.
So I gave him the data, the snapshot, and he took one look at it and said, oh, it looks like you got a gear mesh frequency. Really clear. So we went through the process, and I said, okay, what RPM was it? He goes, oh, it was 1400 roughly RPMs, that was true.
Yeah.
And then from there we proceeded to work back and said, yeah, it's a defect on a gear that has 21 or 22 teeth, I can't remember, something like that. But he picked the number of teeth that was on the defective gear as well from the spectrum. So that was pretty
impressive.
Cool, really cool. And now here we are with the gearbox mounted, and we're going to take another set of measurements, and hopefully the amplitude of the vibration is lower, and the gear mesh defect isn't.
You know what? You'll have to get a screenshot of both of the graphs.
Yeah, we can overlay the graphs as well.
Yeah, I'll chuck them in the video.
So what we really should do is one now, just after the rebuild, before it's run in, and one maybe say 500 to 1000 Ks later after it's run in.
Yeah.
And then we can compare all the readings.
Alright.
Cool.
Alright, well while you fire that up, I'll go bolt my shifter in, and then we'll do some comparisons. So next time you see us guys, we'll have some data, because we won't bore you with the same thing over and over again. Alright, so like usual, it's probably close to midnight now. So it's all back in, we've run it, we've tested it. At the beginning it was still making an intermittent rumbling noise, but we had one of the axles out because we're checking some play in the bearing. That's back in now, we've fired it up, done some more measurements, and after running in a little bit, the rumbling noise, which is the reason we pulled the box out, has seemed to have subsided so far. Touch wood. So yeah, Ben's going to take the data to the people who live and breathe this.
See what they reckon. But so far, after a little bit of running, it's pretty quiet. So
yeah, I was seriously about to just give up on this thing for a while, but it's instilled a little bit of faith. So I've still got plenty more to go for this, especially like I need to do a nice equal length turbo manifold, ball bearing turbo, DDX 3582 probably, and just tidy up a few things once I'm back from my honeymoon and marriage shenanigans. Right. So I guess next thing you guys see, due to the power of editing, will be a soliloquy from Ben explaining
all the things we wanted to know but were too afraid to ask. It's that time of the night.
It's that fucking time of the night. Should we go tune some cars?
Alright, let's put this puppy to rest.